So last week we talked about trig of right angles. So we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That's our first set of definitions. Today we're going to come up with our next set of definitions, our second of three sets of definitions. And this is for trig of any angle. Reminder, our angles from section 6.1, they are positive angles if we rotate counterclockwise, and they are negative angles if we rotate clockwise. And any angle means anything from negative infinity all the way to positive infinity. Okay, so we have to use the stuff from 6.1 to be able to draw an angle in standard position and then be able to use these new definitions. So our new definitions are the sine of an angle is equal to y over r. So I'm just going to pick any point. Okay, this distance between the origin and whatever point I pick is r for radius. This distance here is y, and this distance here is x. So that's the type of information that I'm using. So sine of theta is y over r. Notice r can never be negative because you're always going to have a radius if you have a point that's not on the origin. If you have a point that's on the origin, it's not an angle because you have no way to create the angle. Cosine of theta is x over r. And tangent of theta is y over x, but x cannot be equal to 0. If x is equal to 0, then the tangent of that angle is undefined. There was no such thing as an undefined tangent in right triangle trig because there was no way to get an angle that was 90 degrees or 270 or negative 90 or negative 270 with right triangle trig. Then our other three trig functions, we're just our reciprocal identities from section 6.2. So the cosecant of theta is the reciprocal of sine, which is r over y. And I have to say y not equal to 0. The reciprocal of cosine is secant. So secant of theta is r over x. It's not equal to 0. And the reciprocal of tangent is cotangent. So cotangent of theta is x over y, with y not equaling 0. So when it comes time to do our benchmark test, make sure that you put the restrictions. Anytime you have the capability of having a number that's going to be 0, you need to make sure to put the restriction on the function. R's can never be 0, so there's no reason to write r not equal to 0. If you write r not equal to 0, that's showing me that you don't know that r can't be 0. Okay, it's physically impossible for those to be 0 and still have an angle. Are there any questions on those six definitions? So now we are going to figure out how we're going to use these 6 trig definitions. So what we are going to do is the first group of type of problems we have is they will tell us a point on the terminal side of an angle. Atticus, give me a negative number between 1 and 10. 24. That's not Atticus. Atticus. Yep. Colton, give me a positive number between 1 and 10.
7.
Okay, if you told me 72, that means you need to go back to middle school, okay? So, first step is I want to actually plot the point. Okay, so I'm going to plot negative 5, 7. So, step 1, plot. Step 2, we're going to label our point. So I labeled it. Step 3, we're going to determine R. How do you think I'm going to determine R? Pythagorean theorem. So in this case, it's the square root of 25 plus 49 which is square root of 74. And 74 is 2 times 37. 37 is prime, 2 is prime, so that's simplified. Okay? So we're going to... And once I have this information, I can now write down what the values of all my trig functions are. So the sine of theta. So again, on a test, if I'm telling you to use the definitions, or I'm telling you to use definitions to come up with these trig functions, you must show me that you know the definition. So the first thing you're going to write is the sine of theta is y over r. Then you're going to write your y, which is 7, over the square root of 74. And like I told you before, unless rationalizing the radical is going, the denominator is going to cause things to cancel, you don't have to rationalize for this class. Your calculator, if you were to put this in there, would give you 7 root 74 over 74.
Does the back of the book
They may rationalize. I believe they do rationalize. There will be some that will automatically rationalize just because we use them so much. But these, I'm not going to require a test. So for cosine of theta, we know it's x over r. My x is negative 5 over the square root of 74. Tangent of theta is y over x. Y is 7. X is negative 5. So my tangent is negative 7/5. Cosecant is r over y, which is root 74 over 7. Secant of theta. Oh, by the way, this angle right here is what we're going to call theta. Is x over y, negative r. Thank you. R over x is negative root 74 over 5. And the last one is cotangent of theta is equal to x over y. And that is negative 5/7. Yes. Go. Any questions on that if you're given a terminal point? So we are to the point where we now have a whole bunch of trig angles or angles that we want to have memorized, what their x coordinates and y coordinates are. So what we're going to do is we are going to come up with a table of all of the angles that you are required to know their x coordinates and y coordinates for. So we're going to do 0 degrees. It's what's going to end up being the unit circle, but right now we don't know about the unit circle. Okay. So 0 degrees. Then the next thing we're going to do is we're going to do every multiple of 30 degrees all the way up to 360. So 30, 60, 90, 120, 150, 180, then 210, 240, 270, 300, 330, and 360. 30 degrees is how many radians? Pi radians is 180 degrees. What number do I have to divide 180 by to get to 30? So each one of these that I wrote on here is a pi sixths. So radians, here I've got 0. This one would be 1 pi sixth. 2 pi sixths is pi thirds. 3 pi sixths is pi halves. 4 pi sixths is 2 pi thirds. 5 pi sixths. 6 pi sixths is 1 pi. Any questions how I got the radians for the first group? All I did was add a successive pi sixth and simplified. So 6 pi sixths plus 1 pi sixth is 7 pi sixths. 8 pi sixths would be 4 pi thirds. 9 pi sixths would be 3 pi halves. 10 pi sixths would be 5 pi thirds. 11 pi sixths, pi sixths. And then 12 pi sixths is 2 pi. So that's how I remember what my radians are that go with each one of the pi sixth multiples. The other multiple that we're going to write down is every multiple of 45 degrees between 0 and 360 degrees. So I have 45 degrees, then 90, then 135 degrees, then 180, then 225 degrees, 270, 315 degrees, and 360. So 45 degrees is a quarter of pi. So all I'm going to do is I'm going to do multiples of pi fourths. 1 pi fourth, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths, 8 pi fourths. So that's how I reason myself through getting the measurements there. So what we're going to do now is we are going to think about where these angles are. Okay? And we're going to figure out what their reference triangle is that's going to be associated here. I'm going to leave that on the board. I'm using this right now. So the first things I'm going to deal with, let's get all of the quadrantal angles out of the way. Okay? We're going to get all the quadrantal angles, which are my 0, 90, 270, 180s. So the way we're going to figure out what our trig angles are for a quadrantal angle is we pick on the terminal side. Label its coordinates. So somebody give me an x coordinate for this one. 3, 5, whatever. That can't be negative. What's its y coordinate? 0. So you can pick any point on the terminal side. You can pick any point on the terminal side. Okay? So our sine, cosine, and tangent of these particular angles. Well, sine is y. Well, what's r in this case? How long is it between here and here? Okay, so sine is y over r. 0 over 3 is 0. Cosine is x over r. 3 over 3 is 1. Tangent is y over x. 0 over 3 is 0. Atticus, give me a coordinate for that point. 22. Okay, 0, 22. What's the distance between the origin and that point? Okay. So again, I'm doing all the quadrantal angles first. So sine is y over r. 22 over 22 is 1. Cosine is x over r. 0 over 22, 0. And tangent is y over x. 22 over 0 is undefined. Lane? Yeah. Give me a coordinate for right here. -2. Comma? 0. Okay. How far is it between here and here? 2. R's are never negative. Okay? It's a distance. It's a length. Okay? So the R is never negative. So sine is y over r. 0 over 2 is 0. Cosine is x over r. -2 over 2 is -1. And tangent is y over x. 0 over -2 is 0. And Ben, give me a coordinate.
45.
45? That's not a coordinate.
0, 45.
That still wouldn't be that coordinate.
Oh,
It's
0,
got to be a
negative
-45.
45.
Okay? And what's the distance between here and here?
45.
R is a positive 45. Remember, your R's are always positive. So sine is y over r. -45 over 45 is -1. All right, sine, cosine, tangent. Cosine is x over r. 0 over 45 is 0. And tangent is y over x. Undefined. And when we get all the way back around to 360, I can use that point again, which is going to give me the exact same things I had here. Any questions on our quadrantal angles? So the next angle I'm going to draw is the angles that have these 6 that are left in them in simplified forms. I'm going to do pi 6, 5 pi 6, 7 pi 6, and 11 pi 6. And what we're going to do is we are going to use our memorized 30, 60, 90 triangle to come up with what those are, what the coordinates are. So the first one is pi 6. Pi 6 is 30 degrees. Notice that 150 degrees, that's 150. What's this angle right here?
30.
30. So this one is 150. If I come down here to 210, what's this angle right here?
30.
That's the reference angle. Our reference angle is the angle between the x-axis, it's the acute angle, between the x-axis and the terminal side. Our reference angles are always positive angles, so they're going to be an acute 0 to, it's between 0 and 90 degrees. And my last, so this is 210. This is 30. And the last one would be 330 degrees. That reference angle is also 30 degrees. Forgot a 0 here. Our memorized sides of our 30-degree triangle are 1, 2, square root of 3, where 1 is the shortest side, 2 is the hypotenuse, And the square root of 3 is the middle side. So 1, 2, square root of 3. 1, 2, square root of 3. 1, 2, square root of 3. Notice I labeled every one of those side lengths with positive numbers. Why is that?
They're distances.
They are distances. So my next step is to label the coordinate on the terminal side. So I'm going to label it. Well, x is square root of 3. Y is 1. X is square root of 3 in the negative direction. And y is a positive 1. X is negative square root of 3. Y is going to be negative 1. X is positive square root of 3. And y is negative 1. So notice when you draw your reference triangle to start filling in the numbers, those sides on the triangle are positive always, where we take into account which quadrant we are in or when we're labeling the point on that terminal side of the angle. Any questions on that? So now we're just going to go through our definitions. So pi sixths, y over r, 1 over root 3.
2.
Oh, yeah, 1 over 2. Y over r, 1 over 2. X over r, square root of 3 over 2. Next one is y over x, 1 over root 3. And that one we will rationalize as square root of 3 over 3. Because that's the way you're going to see it most of the time. The next one I can go down to is 5 pi sixths. Y over r, 1/2. X over r, negative square root of 3 over 2. And y over x is negative 1 over root 3, which would be negative square root of 3 over 3. Seven pi sixths. Y over r, negative 1/2. X over r, negative square root of 3 over 2. And tangent, negative 1 over root 3 would be the positive square root of 3 over 3. The last one here is negative 1 over 2, negative 1/2. Square root of 3 over 2 positively. And negative 1 over root 3 would be negative root 3 over 3. What's my next angle I'm going to draw?
45.
Let's do the 60s. Oh, let's do the 45 since you asked for it. That's 45. I'm going to draw a 45-degree reference angle in each quadrant. Okay, this is 45 degrees. This would be 225. This would be, no, this is 225.
135.
This one's 135. And this one would be 315. All I did is I added 90 to each of the quadrantal angles. What are my memorized sides of an isosceles right triangle?
1 square root of 2.
1, 1 square root of 2. 1, 1 square root of 2. 1, 1 square root of 2. 1, no, square root of 2. 1, 1. 1, 1 square root of 2. Now I'm going to label the coordinates of this endpoint. That would be 1, 1. This is negative 1, 1. Negative 1, negative 1. 1, negative 1. So sine 1 over root 2 which is the square root of 2 over 2. Cosine, 1 over root 2 is square root of 2 over 2. Tangent of 45 is what?
1.
1. 1 over 1 is 1. Next angle. I'm going to have a positive sine. I'm going to have a negative cosine and a negative tangent. Do you guys see that?
Yeah.
So I'm going to have a positive sine, square root of 2 over 2, a negative cosine, negative square root of 2 over 2, and a negative tangent, negative 1. For 225 degrees, negative sine, negative cosine, positive tangent. Negative sine, negative cosine, positive tangent. And you should start seeing right now that, hey, everything that I did in blue, all the numbers are the same with the exception of the signs. S-I-G-N signs, not the S-I-N-E signs. What I'm doing in red, all of the numbers are the same with the exception of the signs. So my last one, negative sine, positive cosine, negative tangent. Negative sine, positive cosine, negative tangent. Because we know they're all the same, if you know what your basic reference angles are for your memorized triangles, you can think about the signs using the following acronym. Starts here in quadrant 1 with A, then S, then T, then C. And we're going to write all students hate calculus.
No. Why?
Okay? So what does this mean? This means everything is positive. So this one means all positive. This one means that the sine is positive and everything else is negative. This one means that the tangent is positive, and this one means that the cosine is positive. And this is for our first three primary trig functions. The cosecant is going to be the same sign as the sine. The secant is going to be the same sign as the cosine, and the cotangent will be the same sign as the tangent. But so two ways to do it. One, you can memorize the entire layout. Two, you can think about the one right triangle and then adjust the signs. My recommendation is you actually draw the triangle in reference position, label the side lengths, label the endpoint, and actually use the definitions. So we are down to our last four. So these will be the 60s, right?
Yeah.
And 60s are pi thirds. You guys should automatically be into the point that you know that 30 degrees is pi sixths, and pi sixths is 30 degrees. 60 degrees is pi thirds, 45 degrees is pi fourths. That should become automatic for you. You shouldn't need to do the calculation in order to do any of these angles that we're doing. So we're going to do 60 degrees, 60 degrees, 60 degrees, and 60 degrees. So again, this is a 30, 60, 90 triangle where my side lengths are 1, 2, square root of 3. 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 Label my coordinates. My coordinates are going to be 1 comma root 3. Coordinates here would be negative 1 root 3. Coordinates down here would be negative 1, negative root 3. And this would be positive 1, negative root 3. And we fill in our blanks. Y over R, square root of 3 over 2. x over r, 1/2. Y over x, square root of 3 over 1, which is square root of 3. Okay, now that I'm in quadrant 2, I know that signs are positive, everything else is negative. And I can just copy these numbers. Square root of 3 over 2, 1/2, square root of 3. When I'm in quadrant 3, I know that tangent is the only one that's positive. You can copy those numbers. Square root of 3 over 2, 1/2, square root of 3. And in quadrant 4, the only one that's positive is cosine. Copy the numbers. Square root of 3 over 2, 1/2, negative square root of 3. Those are expected to be memorized or easily obtained values for those trig functions. Okay? Anytime that you have one of these on a test, it will be a no calculator portion of a test. So you need to basically be able to draw the reference triangle, label the sides, and then come up with the sine, cosine, and tangent of those. Any questions on those angles? I'm going to leave this one up there. I'm going to erase my reference triangles. We're going to go back to section 6.1 and do a little bit of discussion and see what people are thinking about. Everything we've done so far are trig functions of angles. You guys agree with that? These are all angles. Everything from 6.2 was an angle. Everything right now has been an angle. Well, I can take trig functions, not just of angles, but I can take trig functions of any real number. And let's talk about that. This is a circle with a radius of 1. I'm not going to talk about it as a unit circle right now. So I have a question for you. If this distance is 1, and this distance is 1, and I take, so that's a length, right? It's a length of 1. And I were to take, is it the same length as this?
Yeah.
If I were to take that length, instead of making it straight, were to come around here and lay it off on my circle, it would end about there.
Yeah.
Okay? What would that angle be in radians?
That is pi fourth. No.
Yeah.
This is S, right? Arc length? What's my arc length?
1.
What's my radius?
1.
And we know that S is equal to R theta. Well, S is
1.
Radius is
1.
theta is
1.
1 radian. That's our definition of a radian. So this is a distance. And I can take that distance and I can lay it around a circle if I'm using radians.
Would that be 60 degrees?
No,
What would
it's 1 radian.
No degree.
It's whatever.
Whatever it converts.
If pi radians is equal to 180 degrees, what number do I have to divide pi by to get to 1?
I.
So if I divide the left-hand side by pi, I divide the right-hand side by pi, and it's a little less than 60 degrees. But we don't use degrees. Once we start dealing with real numbers, we're not using degrees. We are not going to think about it as an angle anymore. We're thinking about it as a distance. We're thinking about it just as a number. And that number I can convert to radians with S equals R theta. Okay? So my distance, let's say I had a distance of 10. Could I wrap that distance of 10 all the way around the circle?
Yeah.
Could I have a distance of 100 that I wrap around a circle? So that's how we can get trig of any number, okay, without them thinking about angles. The reason why I drew this picture is so that you can see that, hey, yes, I have an angle here, but it came from a distance. Okay, it came from that distance that I actually wrapped around the circle. So yes, we're going to be taking Trig's functions of angles, but the reason why we're going to be able to take trig functions of angles with these other numbers is because there is a relationship between length and an angle measurement. Any questions about this relationship? Our next identities that we need to know. The sine of a negative angle is equal to what relationship to the sine of the original angle? So let's look at this. Sine of 30 degrees is 1/2. The sine of negative 30 degrees is negative 1/2. What's its relationship?
It's the opposite.
It's the opposite. This relationship right here is what makes sine an odd function. Remember, odd functions are those that have symmetry if rotated about the origin. Okay? That relationship there is what gives us sine being an odd function. Let's take the cosine of a negative angle. So cosine of 30 degrees is square root of 3 over 2. Cosine of negative 30 degrees is square root of 3 over 2.
Equals the cosine.
Cosine of a negative angle is equal to the cosine of the original angle. Anytime we have this relationship that the function of a negative input is the same as the function of the non-negative input, it's called an even function. And later this week when we go to graph sine and cosine, we will see those two graphs that are up on the left-hand side, and you can see them graphically being even and odd functions. So some call these the negative angle identities. Our book, I believe, calls these the even-odd identities.
Thanks.
These are the only two I'm going to require you to memorize, because every other one you can come up with by using other identities you know. Let's talk about tangent. How would you come up with tangent? Tangent of a negative angle.
They call it even odd.
Well, but what's tangent? What's an identity you know that for tangent that includes things you already know?
Sine, tangent equals sine plus cosine.
Okay, tangent is sine of the angle divided by cosine of the angle. Well, sine of a negative angle is equal to negative sine of the original angle. Cosine of a negative angle is the positive of the original angle. Well, sine over cosine is tangent with a negative in front of it. So the reason why I don't have you memorize this identity is because you can come up with it with your reciprocal identities. Saves hard drive space. Okay. Any questions on those before we do some example homework? Do you want me to do some example homework? Please turn your book to page 455. So if you look at your homework thing, it says 3, 6, blah, 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 blah. You guys are doing every third problem from that big list I gave you. Okay? So I'm going to do some of the non-assigned homework. I'm going to do one of the non-assigned homework problems from each section that you're assigned homework. So you start out with 5. So the first one I'm going to do is number 6. So 6, they give me two figures. The first figure, it rotates around here. Negative 12, negative 5. And that's theta. The second figure rotates all the way around here to 1, negative 1. And that's theta. What it wants is the values of the 6 trig functions, the exact values of the 6 trig functions. Anytime it says exact, that means no calculator. So we have a point on our terminal side. My next step was to find what?
The radius.
The radius. Well, I have a 5, 12, what triangle?
4. No.
13. Okay? That's one of our Pythagorean triples. I would expect that you know that one. Okay, just like 3, 4, 5. I expect you to know that. So you don't have to use, Pythagorean theorem. So sine is y over r, which is negative 5 over 13. Cosine is x over r, which is negative 12/13. Tangent is y over x, which is negative 5 over negative 12, which is a positive 5/12. Cosecant is r over y, which is negative 13/5. Secant is r over x, which is negative 13/12. And cotangent is x over y, which is 12/5. For this next one, because we're running towards the end of class, all I'm going to do is we're going to find out what r is. So if I have a side length of 1 and 1, what's this length going to be?
Square root of 2.
Square root of 2. Okay. Any questions on that?
No.
So the next group you have, it says in exercises 9 to 14, the point is on a terminal side. Determine the exact of the 6 trig functions. I am going to do 12, which is at negative 4, 10.
This is pretty much the same thing.
Yep.
Give us the picture.
Well, all I'm going to do, this one doesn't give you the picture, so I want to plot the point of negative 4, 10, label it, draw my triangle, and come up with the missing side. Well, this would be the square root of 116. Okay? Well, what's the square root of 116? What perfect square goes in there?
100 or 10.
No, 10 doesn't go into here perfectly.
Oh, into 16.
Out of 116.
Okay.
That's 4 times
29.
25 plus 4 is 29, right?
Yeah.
So I have the square root of 4 times the square root of 29.
2.
That's prime. So that's 2 root 29. So that's how we're just going to come up with the r. Okay, we're going to want our r's in simplified form. Okay, so sine is y over r, 10 over 2 root 29, which is 5 over root 29. That's all the simplification I need to do on that one. Cosine is x over r,
So it's 2.
which is negative 4 over 2 root 29, which would be negative 2 over root 29. And tangent, y over x, 10 over negative 4, which would be negative 5 halves. And your other 3 functions are just the reciprocals of these. Any questions on how to do it if they just give you a point? Your next group of problems, they tell you whether sine, cosine are positive or negative, and they ask you what quadrant it is in. Okay? If sine is positive, that means you're above the y-axis. If cosine is positive, that means you're to the right of the x-axis, the y-axis. If sine is negative, you're below the x-axis. And if cosine is negative, you're to the left of the y-axis. Tangents are positive in quadrant 1 and quadrant 3. Tangents are negative in quadrants 2 and quadrants 4. So you use those facts to tell me what quadrant your angle's in. So problems like 19 through 28, they give you a trig function of an angle, and then they tell you a quadrant or enough information to find out a quadrant. I am going to do problem number 25. 25 says the secant of my angle is -2. The other fact that they give me is that the sine is negative. Secant is 1 over what? No, secant's 1 over cosine. So cosine is negative and sine is negative. What quadrant are both sine and cosine negative?
That would be quadrant 3.
Quadrant 3. So you're going to draw a quadrant 3 angle. Okay, so you're going to draw the angle in the correct quadrant. Now what we're going to do is we're going to label our angle. And we know that secant is r over x. So think of this as -2 as negative of 2 over 1. R over x. Can r be -2? That means my x is -1. My r is 2. This is 1. Those are the memorized sides of a 30, 60, 90 triangle. So what's this length? Square root of 3. So my y-coordinate would be -√3, and then I would use this fact to come up with the other trig functions. Any questions on using the facts from two different trig functions to come up with what quadrant you're in? Next group is trig functions of quadrant angles. The next group has you graph things in, find the reference angle and sketch those two angles. And the last group has you doing trig functions of memorized ones. So that's that board on the right. And then your last group, I'm going to do 66. So I'm going to write something on the board. 66 is kind of like what I just did here. (66) says the cotangent is -3. It tells me I'm in quadrant 2. And they just want to know the sine of theta. So what I'm going to do is I'm going to draw a quadrant 2 angle. My cotangent is equal to x over y. Think of this as -3 over 1. Which one of these, x or y, can be negative in this quadrant? The x is negative. So the y is 3. So this distance is 1. This distance is 3. Now I've got to come up with radius because they want sine, so I need the radius. So that's square root of 10. So the sine is 3 over root 10. Any questions?